In this lecture, we're going to learn about constant iterators. And a constant iterator is one you can't go through to modify what it is pointing to. So here we have a simple example. We have our begin iterator and our end iterator. If we want, for example, we can go through the begin iterator and modify the 10 as we saw in the last lecture, but constant iterators are going to forbid you from doing something like this. If you have a constant iterator, you can't go through it to modify the value that the iterator is pointing to. That's the main thing you can achieve with constant iterators. So here we have a simple example. We have a vector here and we are looping, changing each element to 100. This is going to work by default because the iterators you get by calling the begin and end methods are non-const. So you can go through them to modify what is actually pointed to by the iterator. If we print our collection here, we're going to see that now the numbers vector contains all hundreds because we changed each instance of elements in our collection to 100 here through this loop that we did. Now, it is possible to set up constant iterators that forbid you from doing something like this. And there are different ways to get hold of constant iterators. One is to explicitly say that you want a const iterator using std vector and const iterator if you are working on an std vector, and this is going to give us a constant iterator. Another way is to use the cbegin method, which is also going to return a constant iterator you can't use to modify what is pointed to by the iterator. We can also go through return type deduction and use auto here, and this is going to give us a constant iterator. If we try and loop through our collection and try to modify through dereferencing like we do on this line here, this is going to give us a compiler error because we can't go through a constant iterator and modify the data that is pointed to. If we try to do that, we will get a compiler error. We can also have constant reverse iterators, and we get access to them by using the crbegin and crend methods. And if we try to go through these iterators to modify the data, we will get a compiler error. This is the design. And another way to get a constant iterator is to call begin or end methods on a const container. So for example, we can set up a const vector of int, and saying that this vector is const is that we can't really modify it in any way. So if you're trying to get iterators to this container, the system is going to give you constant iterators. You can't go through to modify any element from this container because the system is going to protect the constantness of the container. This is what we can achieve by setting up a const container. You can't go through any iterators you get from this container to modify the data inside the container. If you're trying to do that, you will get a compiler error. Now that you know these things, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is constant iterators. We will grab the code from our template files and use that. So let's do constant iterators here. And let's open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our file. And we're going to include vector because we're going to need that. This is our sandbox container we are using to learn about all these crazy concepts. So let's put in vector here. And we will create a vector of integers just like we did before. This is going to be called numbers. Once we have this, we can really set up any kind of iterator. We're going to set up a regular non-const iterator just to start here. So we're going to say std vector iterator. We want a vector of int and we want an iterator we can use to navigate through our container here. And this is going to be it. We can call it whatever we want. And this is going to be numbers begin. Okay, we can say something like this, and this is going to be an iterator we can use to not only navigate and read data from our container, but we can even go through our iterator and modify the data. So we can go down and say something like this, and we're going to say while it is not equal, and we're going to go through our container and try to modify the data in our collection. We're going to go through our iterator and change any piece of data to 100 through our loop here. Now we can go on top here and set up our print collection function, which is going to print our collection to be able to see these things easily. This is something we have seen before. So let's do that. We're going to go on top here and print the data before we modify it. So we can say stdc out, and we're going to say numbers. This is called the numbers. So let's put that right here, and we're going to say print collection, and we will print numbers. We will modify the data and print numbers again, and we're going to see that the data has changed. So we're going to say print collection, and what we want to print is numbers, and this is going to work really well. So let's pass this through our compiler, but before we do, let's go through this. We have our container which contains from 11 all the way to 77. We're going to print the numbers, and we're going to see exactly what we see here, but we're going to loop through our collection, changing any instance of element in our collection to 100. So if we print again, we expect to see only 100s printed out. So let's print numbers. We're going to say stdc out. We want to print the numbers collection. You can say that like this. And if we pass this through our compiler, we're going to see that the build is good, and we can bring up a terminal window and try to run our application. If we run Rooster, we will see that now we have a problem and we have a crash, and let's investigate why we have this problem here. Oh, we are not incrementing our iterator to move forward. This is going to loop indefinitely. That's why we have this little thing here. We can hit Control C. You can see the kinds of problems you can run into if you forget incrementing your iterators. This is a good learning experience. So let's do ++it to move to the next element. And if we build and run again, the build is good. Let's clear and run Rooster. Now everything is going to work. You're going to see that for the first time, we're going to have the data, and we're going to loop and go through the iterator to modify the data that is in our collection. This is something you can do with non-const iterators. You should really know this. Now we're going to go down and set up a separator, and we're going to set up a bunch of constant iterators. So what we can do is grab what we have here, for example, and we can refactor or change this a little bit. We're going to have std vector, and we want to say that we want a const iterator. This is something we can do. And if we do begin, the compiler is going to give us a const iterator. We can't go through to modify our thing, but it is much more descriptive to really use the cBegin method. And the C in front here is going to mean that you want a const iterator. So this is much more self-documenting, and I do recommend doing things this way. So if you want a const iterator, say it through the cBegin method. So we are going to be comparing our iterator here. Let's say cit to really make it super clear that that's what we want. And we're going to say cit here. And you see that the moment we do this, we have a squiggly line here because this is a constant iterator. We shouldn't be allowed to dereference it and change the data because this is a constant iterator. You can't go through the iterator to modify the data the iterator is pointing to. If you do that, you will get a bunch of compiler errors. So let's comment out the code we had before that modified our data and make sure that we only have what we put in, 11 all the way to 77. And if we build our code, we're going to see that we will get a compiler error. And the compiler error is going to say we can't go through a constant iterator and modify the underlying data in our container. Let's go on top and see if we can find the error. So we have error assignment of read-only location cit. So this is a constant iterator. We can't really modify what is pointed to by this iterator. But note that it is possible to increment a constant iterator and make it point to a different location. That's what we see on line 42 here. So this is possible. What is not allowed is to go through the iterator itself and change what the iterator is pointing to, but the iterator itself can be changed to point somewhere. I want you to keep this thing straight in your mind because some people get really thrown off by this. Now, this is what you can do with constant iterators. It is also possible to do auto type deduction. For example, we can say auto and say cit and say numbers cBegin. This is going to give us our iterator, and it is going to protect us from being able to change things through our iterators. Again, if we build the program, we will see that we will get a compiler error, and the error is going to be the same assignment of read-only location, so we can't really do this. And if we take out this line and comment it out and build and run again, we're going to see that the build is going to be good this time. It is also possible to have constant reverse iterators, and we do that through the CR begin and CR end methods. So if we go down and do something like this and set up a reverse iterator, which is const through return type deduction here with auto, we're going to get a constant iterator. And again, if we try to go through this iterator to modify our data, we will get a compiler error. This is really all I had to share in this lecture, raising your awareness on const iterators. And if you happen to need them in whatever problem you are trying to solve with C++, take advantage of them and really design your applications in the best way you can. We are going to stop here in this lecture. The next one, we are going to zoom out and really have a bird's eye view on the kinds of iterators we can have in our C++ programs. Go ahead and finish up here and meet me there.